Resonant pulse converters. In previous videos, we have seen the converters with the pulse width modulation control to synthesize the desired output voltage and current. However, the devices are turned on and off at low current with high di by dt value. The switches are subjected to high voltage stress and the switching power losses of the devices increases linearly with the switching frequency. The turn on, turn off losses could be significant portion of the total power loss. The electromagnetic interface is also produced due to high di by dt and dv by dt in the converter waveforms. So these are disadvantages of pulse width modulation control can be eliminated or minimized if the switching devices are turned on and off when the voltage across the device and or its current becomes zero. The voltage and the current are forced to pass through zero crossing by creating an LC resonant circuit, thereby calling a resonant pulse converter. And resonant pulse converters can be classified into 8 types. First one, series resonance inverter. Second one, parallel resonance inverter. Third one, class E resonance converter. Fourth one, class E resonance inverter. Fifth one, zero voltage switching resonance converter. Sixth one, zero current switching resonance converter. This is known as ZVS and this is known as ZCS. Seventh one, two quadrant zero voltage switching resonance converter. Finally, eighth one, resonant DC link inverter. So these are the 8 types of resonant pulse converters. Now let us see the series resonant inverter. The series resonance inverter are based on the resonant circuit oscillation. The commutating components and the switching devices are placed in series with load to form an underdamped circuit. The current through the switching device, this is nothing but thyristor, transistor, BJT, MOSFET, whatever it is, falls to zero due to the natural characteristics of the circuit. If the switching element is a thyristor, it is said to be self-commutated. This type of inverters produces an approximately sinusoidal waveform at high output frequency, ranging from 200 Hz to 100 kHz, and is commonly used in relatively fixed output applications like induction heating, sonar transmitting, fluorescent lighting, ultrasonic generators. Due to the high switching frequency, the size of the commutating components is small. Here, the commutating components is nothing but inductor and capacitor, LC resonance circuit, right? There are various configurations of series resonant inverters depending on the connection of the switching devices and the load. The series inverters may be classified into 2 types: series resonant inverter with unidirectional, series resonant inverter with bidirectional switches.